Hello everyone. Once again, 2 days in a row to report some breaking news for Quant Network, and it is Martin Hargreaves this time around. So before we jump into it, just a quick reminder, smash that like, hit the bell notification if you haven't done this already. Let's just get right into it. Everything is adding up so beautifully because, again, it's the latest developments of what we're doing in regards to digital payments, and more in particular, the whole thing of shaping the future of finance. Martin Hargreaves, Quant's Chief Product Officer, is sharing his insights on the digital pound and the RLN in the UK. And here's the key thing. This happened a few hours ago, right? Well, in my findings, why I'm bringing it to you guys, it gets into more of the weeds of, again, why we should pay attention to this. So he was at this, and what's really cool, when you zoom in, you see that he's sharing a lot of this, and it's Quant's expertise in regulated tokenized money. Like it says, they highlight the whole thing of 2022 with LACchain. They highlight the whole thing of 2023 with Project Roslyn. But again, this key highlight of 2024 in regards to the RLN. As I get more further into this, I want to bring this to your attention because it is the whole thing of this summit. It's a 6th annual Digital Transformation in BFSI Summit. And basically speaking, happened earlier today in Amsterdam, Holland, aka the Netherlands. You have some key people here. And where I'm going with this is understanding, first, to get into the guy on the far left. His name is Anil Idnani. He's the head of compliance and MLRO. Now, again, think about this. Head of compliance? Gilbert Verdian's call to action in regards to, or final warning about compliance and getting on board, because there's going to be a radical shift happening soon. And lots of talk, especially when it comes to, what's going on with the UK government. Last video I talked about that, right? As we get further into it, I decided to get more into this particular person because, as you see, he has an extensive experience in financial compliance and regulatory oversight. Yeah, all this is coming together. Anil leads the bank's efforts in maintaining rigorous standards of integrity and transparency. His expertise encompasses anti-money laundering, AML strategies, regulatory compliance, boom, there we go, and even risk management. And of course, says it makes him a key figure in safeguarding the bank's operations and reputation. That is adding up very, very well. Now, in the thumbnail, you saw the whole thing in regards to AI, but it's more to it than just AI. It's understanding that Gilbert Verdian has a robust background in regards to what? Cybersecurity. And I thought I would introduce this. It's Salience. Of course, a few videos back, I introduced a little bit of this and explained, how Quant is, basically speaking, the matrix of blockchain, right? And if you haven't seen that deep dive video, I will put it at the end. Salience is an AI-powered attack surface management and risk quantification platform. Gotta love the little hints of Quant. This was published May 29th of 2023. But again, understanding cutting-edge AI-powered attack surface management and risk quantification platform, Quant is so much bigger than we realize. Going to go ahead and play this. Minute 18, we'll come right back. I'll show you some other key things on why all this matters, especially if you hold QNT or you're possibly looking to get into it. Here we go.
The business world is changing faster than ever before. Companies are more connected than ever, but that connectivity comes at a cost. With every new connection, businesses expose themselves to new risks. What worked to protect your business yesterday may not work today. Take immediate mitigation steps to avoid the costs of data breaches, reputational damage, and third-party risks. Elevate your cybersecurity posture with Salience. attack surface management and cyber risk quantification platform. Whether you're a tech-savvy professional or a business decision maker, Salience offers a comprehensive view with two unique modes, business and expert. Our cyber AI and laboratory knowledge-powered platform, Salience, uses continuous and automated penetration testing, vulnerability assessment and prioritization, cyber risk quantification, security profile scoring, third-party risk management, risk remediation playbook to identify security weaknesses, vulnerabilities, and missing configurations in an organization's assets from an adversary perspective. Get role-based reports with mitigation tips and take hardening actions. Humanize your company's cybersecurity. Put tech people, CEOs, and the board on the same page when it comes to cybersecurity. Stay cyber secure. Stay compliant. Salience, powered by Humanize.
So, a key word for you guys moving forward in this outline is humanize. Try to remember that. As we get to the next part, I want to present this to you and just kind of give you a little reminder. And that is basically outsmarting cyber threats. Again, back to Gilbert Verdian and his robust history in regards to cybersecurity. As I share the actual website with you, let's take you to there. It is on the URL humanize.security. Now, in the highlights that we're going to get into, you will see all sorts of things. Number one, products, solutions, case studies, pricing. It's all there. But again, outsmart cyber threats and protect your attack surface. Simplify your cybersecurity journey with Salience. And as I get further into it, look at some of the key things. Like it says, extended attack surface management and risk quantification solution for C-suite executives. Mentions the whole thing of API attack surface. Talks about the whole thing on your right side of the screen about unrestricted resource consumption, broken object level authorization, unsafe consumption of APIs. And as we get even more into this, look what it mentions in regards to improving cybersecurity with extended attack surface analysis. But I love these statements because, you know, how many times do we talk about, is the token you're into a honeypot? Well, this has honeypot intelligence and advanced API security using Salience's XASM platform for optimized cybersecurity return on investment. Very interesting to see this. And it gets better because, you know, for about 3 years now, we have studied the whole thing on Quant. And now we got this whole thing of the RLN and all the talk about how the RLN basically connects to what? A unified ledger. And the terminology adds up. The unified extended platform that maps and analyzes your entire digital sphere, external, internal API. Yeah, it's all there. And more importantly, it's understanding all of these key things. And again, I don't want to do a deep dive necessarily about, you know, what you see on the website, but when you go further into it, it brings you to, again, that video that I just showed you. But you can see here about how this platform takes Quant to a whole other level that sometimes that we're distracted with all the other talk about CBDCs, tokenized deposits, you know, what they're doing in that realm. And then there's this whole other realm that a lot of people just aren't really truly aware of. And as I get further down to the bottom, look what it says in regards to humanized cybersecurity systems, or solutions, I should say, for, and like it says, telecom and IoT. I mean, Gilbert Verdian, he has a background in that, and I'll get into that just in case you're new. Insurance, software as a service, you know that's going to be mentioned at some point. Government agencies in the middle, finance and banking, and boom, there's Laura Verdian's plug to healthcare sector. Yeah, it's all there. All this matches. All this adds up. And when we talk about, for example, Gilbert Verdian's background, even when it comes to the Federal Reserve and so on, well, that links to what? The New York Reserve, or Fed, you know, the New York Fed for New York, right? The Reserve Bank of New York, I should say. And so what do you have even here? New York-based insurance leader fortifies data security and compliance with Salience. And it's like, oh my gosh, all this adds up. And at the end of the day, some people say, well, how do you say quant without saying quant? And again, we're going to confirm some things, in my opinion. Again, none of this is financial advice. It's just research. But remember that video I did a few videos back? Again, I showed you some of this. You know, how the Quant logo is literally a representation of one of those squids, one of those sentinels. So you see here that Sentinel discovers new business insights by linking machine activity to what, everybody? Human behavior. That adds up. And then what do you see right below that? Salience. And that was, again, back from that old site that we shared in the Wayback Time Machine. But it keeps getting better and better because I told you guys, or mentioned, I should say, excuse me, about the whole thing of, telecommunications. So what do we have in regards to that reference? Well, boom, here you go. Vodafone highlights silicon photonics push. This was posted originally from Stuart Wills. But the international telecommunications firm Vodafone has announced a significant expansion of its R&D campus in Malaga, Spain, and reported the facility upgrade with a pointed nod to silicon photonics. Specifically, Vodafone noted that it was partnered with two startups, Spain-based Ipronics and UK-based Salience Labs, to explore the potential for new silicon photonic chips to become the hardware of choice to drive the customer-focused mobile networks of the future. Wow. Because as we know, when it comes to Gilbert Verdian, we know his connections to Vodafone. Been there, done that. And I'll, again, pound that home just in case you're new. Because guess what? More news about this. In fact, this time around, October 1st, today, okay? And look what it says. This is from this particular gentleman, Sashi Danand Singh, who's part of this thing called diverse interest in all these other particular things. But he reported that from Vodafone Idea, which is VI, they're set to close around this particular price, with this 13,200, I think that's rupees if I'm not mistaken, crore deal with Sweden's Ericsson, and another 3,300 crore deal with South Korea's Samsung. I was mistaken on that. Don't quote me on that particular currency. But the key thing is Vodafone. This week to do what, everybody? Buy equipment for its upcoming 4G network expansion and even 5G rollouts. How so? Well, let's also go ahead and put this on the other screen, because what you'll see here is something definitely worth pointing out, because it's understanding the equipment that will be used, but more importantly, understanding the terms of payments. As you see in the picture illustration, VI is reckoned to have given strong assurances to Ericsson, Nokia, and Samsung about LCs, but it's the letters of credit to be furnished with reasonable time frame to enable vendors to execute first round of purchase orders. LCs would have to be issued by banks, guaranteeing that VI's payments to vendors for its 4G, 5G gear buys would be received on time for the contracted sums. Again, tokenization, and again, smart contract solution. All of this simply makes sense, and more importantly, simply adds up. As I get into the next part of why I'm sharing this, what about the whole thing about Quant Network and Salience? Well, is there any reference? Why would Gilbert Verdian like something like Humanize? Gee, I wonder why. Think about it. And as you see here, Salience, powered by Humanize, and like it says, Halloween 2023. We're now 1 year away from that particular point. We're literally in the Halloween month of 2024. But interesting to see that Gilbert Verdian likes this. More importantly, when we talk about some of these key things, sometimes people, when they hear talks about interoperability, they're like, yeah, there's things like Corium, there's things like Dot, there's things like Cosmos. This is not fun against those. I like those projects, by the way. I think Cosmos is a great staking platform, and they got a lot of use case, right? And Dot, Polkadot, fantastic layer 0. But QNT, listen to this analogy, is a layer 7 interoperability. This is a great analogy. There's no middleman or middle chain. There's no bottleneck. There's no limitations like Dot, Cosmos, crypto projects. They will need to connect and operate through it, or risk becoming obsolete, in isolation. It's only a matter of time before this fact becomes undeniable, I should say, to everyone. Quant interoperability at scale has finally been solved. That, of course, was post 2021. Such a great analogy, such a cool looking picture. As I take you to the next part, because we mentioned the whole thing about bottlenecking, this is from the technical side of things. This is from Chaitanya K. Joshi, a PhD student over at Cambridge, research intern over at Alet Meta, okay, which is, the AI division of Meta, really interesting. And he's also over at this thing called Fair Chemistry, previously known as the Catalyst Project. He's interested in deep learning and basically for biomolecule design. Think about that. So I know this is technical, but it'll just make it brief. He mentions the whole thing of on the bottleneck introduced by attestation as a GNN aggregation function, packing information to a single attention weight as opposed to a dim message regularizes the model. He finds this concept very beautiful and elegant. Like, it makes you wonder if people like this know about quant, right? And here's where it gets really beautiful, because again, we could talk about those other projects and their quote unquote interoperability, but do they have it at scale? And that's the bottom line, because a lot of times I have people in the comments that post some of this stuff, and nothing against them. Everybody wants their token and coin to do well. I get that. But the three flavors of GNN layers, more computationally scalable versus more theoretically expressive. Well, you got to have a practical middle ground. And to not elaborate too much into this, because I don't want to bore you with the technical stuff, you have to have something that is not a single scalar, because what does it create in the middle? Bottlenecks. Yeah, bottlenecks. Say what you want in regards to quant, even with the logo. You can see how this all connects. Quant allows for scalability because of interoperability with everything that even claims that they're interoperable. All right. Now, something that we're going to put a lot of emphasis on, all right, before we wrap up this video, and that is this, what you see right here. Has generative AI already basically peaked? Some people are asking that, and some of you guys are wondering, for example, like, man, I just don't get it when it comes to this. This guy will literally mention a need for a solution. Shout out to Shanning, Harold. How do we say quant without saying quant? Listen to this. We'll come back here in just a little bit. Here we go.
So we looked at clip embeddings, right? And we've talked a lot about using generative AI to produce new sentences, to produce new images, and so on and so forth, to understand images, all these kind of different things. And the idea was that if we look at enough pairs of images and text, we will learn to distill what it is in an image into that kind of language. So the idea is you have an image, you have some text, and you can find a representation where they're both the same. The argument has gone that it's only a matter of time before we have so many images that we train this on, and such a big network and all this kind of business, that we get this kind of general intelligence, or we get some kind of extremely effective AI that works across all domains. Right? That's the implication. Right? The argument is, and you see it a lot in the sort of tech sector from some of these sort of big tech companies who, to be fair, want to sell products, right? That if you just keep adding more and more data, or bigger and bigger models, or a combination of both, ultimately you will move beyond just recognizing cats and you'll be able to do anything. Right? That's the idea. You show enough cats and dogs and eventually the elephant just is implied. As someone who works in science, we don't hypothesize about what happens. We experimentally justify it, right? So I would say if you're going to say to me that the only upward trajectory is going to, the only trajectory is up, it's going to be amazing, I would say, go on then, prove it and do it, right? And then we'll see. We'll sit here for a couple of years and we'll see what happens. But in the meantime, let's look at this paper, right, which came out just recently. This paper is saying that that is not true, right? This paper is saying that the amount of data you will need to get that kind of general zero-shot performance, that is to say, performance on new tasks that you've never seen, is going to be astronomically vast to the point where we cannot do it. Right? That's the idea. So it basically is arguing against the idea that we can just add more data and more models and we'll solve it. right? Now, this is only one paper, and of course, you know, your mileage may vary if you have a bigger GPU than these people and so on, but I think that this is actual numbers, right? Which is what I like, because I want to see tables of data that show a trend actually happening or not happening. I think that's much more interesting than someone's blog post that says, I think this is what's going to happen. So let's talk about what this paper does and why it's interesting. We have clip embeddings, right? So we have an image, we have a big vision transformer, and we have a big text encoder, which is another transformer, a bit like the sort of thing you would see in a large language model, right? Which takes text strings, my text string today, and we have some shared embedded space. And that embedded space is just a numerical fingerprint for the meaning in these two items. And they're trained, remember, across many, many images, such that when you put the same image and the text that describes that image in, you get something in the middle that matches. Right? And the idea then is you can use that for other tasks, like you can use that for classification, you can use it for image recall. If you use a streaming service like Spotify or Netflix, right, they have this thing called a recommender system. A recommender system is where you've watched this program, this program, and this program. What should you watch next, right? And you might have noticed that your mileage may vary on how effective that is, but actually I think they're pretty impressive for what they have to do. But you could use this for a recommender system, because you could say basically, what programs have I got that embed into the same space of all the things I just watched, and recommend them that way, right? So there are downstream tasks like classification and recommendations that we could use based on a system like this. What this paper is showing is that you cannot apply these downstream tasks for difficult problems without massive amounts of data to back it up, right? And the idea that you can apply, you know, this kind of classification on hard things, so not just cats and dogs, but specific cats and specific dogs, or subspecies of tree, right? Or difficult problems where the answer is more difficult than just the broad category, that there isn't enough data on those things to train these models in an effective way.
I've got one of those apps that tells you what specific species a tree is. So is it not just similar to that?
No, because they're just doing classification, right? Or some other problem. They're not using this kind of generative giant AI, right? The argument has been, why do that silly little problem when you can do a general problem and solve all your problems, right? And the response is, because it didn't work, right? That's why we're doing it. So there are pros and cons for both, right? I'm not going to say that no generative AI is useful, or these models are incredibly effective for what they do, but I'm perhaps suggesting that it may not be reasonable to expect them to do very difficult medical diagnosis, because you haven't got the data set to back that up, right? So how does this paper do this? Well, what they do is they define these core concepts, right? So some of the concepts are going to be simple ones, like a cat or a person. Some of them are going to be slightly more difficult, like a specific species of cat or a specific disease in an image or something like this. And they come up with about 4,000 different concepts, right? And these are simple text concepts, right? These are not complicated philosophical ideas, right? I don't know how well it embeds those. And what they do is they look at the prevalence of these concepts in these data sets. And then they test how well the downstream task of, let's say, zero-shot classification or recall of the recommender systems works on all of these different concepts. And they plot that against the amount of data that they had for that specific concept, right? So let's draw a graph, and that will maybe make it more clear, right? So let's imagine we have a graph here like this. And this is the number of examples in our training set of a specific concept, right? So let's say a cat, a dog, something more difficult. And this is the performance on the actual task of, let's say, recommender system or recall of an object, or the ability to actually classify it as a cat, right? Remember, we talked about how you could use this for zero-shot classification by just seeing if it embeds to the same place as a picture of a cat, the text, a picture of a cat, that kind of process. So this is performance, right? The best case scenario, if you want to have an all-powerful AI that can solve all the world's problems, is that this line goes very steeply upwards, right? This is the exciting case. It goes like this, right? That's the exciting case. This is the kind of AI explosion argument that basically says we're on the cusp of something that's about to happen, whatever that may be, where the scale is going to be such that this can just do anything, right? Okay? Then there's the perhaps slightly more reasonable, shall we say, pragmatic interpretation, which is like, just call it balanced, right? Which is that there's a sort of linear movement, right? So the idea is that we have to add a lot of examples, but we are going to get a decent performance boost from it, right? So we'll just keep adding examples, we'll keep getting better, and that's going to be great. And remember that if we ended up here, we have something that could take any image and tell you exactly what's in it under any circumstance, right? That's kind of what we're aiming for. And similarly for large language models, this would be something that could write with incredible accuracy on lots of different topics. Or for image generation, it would be something that could take your prompt and generate a photorealistic image of that with almost no coercion at all. Right? That's kind of the goal. This paper has done a lot of experiments on a lot of these concepts across a lot of models, across a lot of downstream tasks, and let's call this the evidence.
I thought you were going to call it pessimistic then. But
it is pessimistic also, right? It's logarithmic, so it basically goes like this, right?
flattens out.
It flattens out. Now, this is just one paper, right? It doesn't necessarily mean that it will always flatten out, but the argument is, I think, that, and it's not an argument they necessarily make in the paper, but you know, the paper's very reasonable. I'm being a bit more cavalier with my wording. The suggestion is that you can keep adding more examples, you can keep making your models bigger, but we are soon about to hit a plateau where we don't get any better, and it's costing you millions and millions of dollars to train this. At what point do you go, well, that's probably about as good as we're going to get with technology, right? And then the argument goes, we need something else. We need something in the transformer or some other way of representing data or some other machine learning strategy or some other strategy that's better than this in the long term if we want to have this line go up here or this line go up here. That's kind of the argument. And so this is essentially evidence, I would argue, against the kind of explosion possibility of that you just add a bit more data and we're on the cusp of something. We might come back here in a couple of years, if you'll still allow me on Computer File after this absolute embarrassment of these claims that I made, and we say, okay, actually the performance has improved massively, right? Or we might say we've doubled the number of data sets to 10 billion images and we've got 1% more, right, on the classification task, which is good, but is it worth it? I don't know. This is a really interesting paper because it's very, very thorough, right? If there's a lot of evidence, there's a lot of curves and they all look exactly the same. It doesn't matter what method you use, it doesn't matter what data set you train on, it doesn't matter what your downstream task is, the vast majority of them show this kind of problem. And the other problem is that we don't have a nice even distribution of classes and concepts within our data set. So for example, cats, you can imagine, are emphasized or overrepresented, yeah. Overrepresented in the data set by an order of magnitude, right? Whereas specific planes or specific trees are incredibly underrepresented because you just have tree, right? So, I mean, trees are probably going to be less represented than cats anyway, but then specific species of tree, very, very underrepresented. Which is why when you ask one of these models, what kind of cat is this or what kind of tree is this, it performs worse than when you ask it, what animal is this? Because it's a much easier problem. And you see this same thing in image generation. If you ask it to draw a picture of something really obvious, like a castle, where that comes up a lot in the training set, it can draw you a fantastic castle in the style of Monet, and it can do all this other stuff. But if you ask it to draw some obscure artifact from a video game that's barely even made it into the training set, suddenly it's starting to draw something a little bit less quality. And the same with large language models. This paper isn't about large language models, but the same process you can see actually already happening. If you talk to something like ChatGPT, when you ask it about a really important topic from physics or something like this, it will usually give you a pretty good explanation of that thing because that's in the training set. But the question is, what happens when you ask it about something more difficult, right? When you ask it to write that code, which is actually quite difficult to write, and it starts to make things up, it starts to hallucinate, and it starts to be less accurate. And that is essentially the performance degrading because it's underrepresented in the training set. The argument, I think, is, at least it's the argument that I'm starting to come around to thinking, if you want performance on hard tasks that are underrepresented on just general internet text and searches, we have to find some other way of doing it than just collecting more and more data, right? Particularly because it's incredibly inefficient to do this, right? On the other hand, these companies they've got a lot more GPUs than me, right? They're going to train on bigger and bigger corpuses, better quality data. They're going to use human feedback to better train their language models and things. So they may find ways to improve this, up this way a little bit as we go forward. But it's going to be really interesting to see what happens because, will it plateau out? Will we see ChatGPT 7 or 8 or 9 be roughly the same as ChatGPT 4? Or will we see another state-of-the-art performance boost every time? I'm kind of trending this way. But, it'll be exciting to see if it goes this way.
Think about what that gentleman said, and if anything, apply it to all the examples that I provided you guys today about scalability. Because when you draw that conclusion, the answer leads back to Quant and what they are getting into, or already have apparently gotten into, dating back, I guess, a few years, but we're not learning or hearing a lot about that. Now we are. To wrap things up, let's jump into this. This is an old reference from June, but it pounds home everything. As you can see here, you have from June 18th, like it mentions, we have the technology, says this particular person from Forbes, David Whiskey Tango Foxtrot Birch, right? Author, advisor, thought leader in digital financial services, global keynote speaker. Again, I've shared this before, but he's over at Forbes and Financial World contributor. And basically speaking, yeah, we have the technology. And of course, Quant Network says, we do, Dave. We are, quote, the foundation of digital finance. Now, here is something really cool, because this was back last summer at EBA Day 2024. What's really, really cool here is some of these key things about, is this a new slogan for Quant? The answer is yes. Before, the slogan was the foundation for building on blockchain, ISO TC 307. I don't know if you guys caught this at the beginning of the outline. Some of you guys did. But here it is. Let's wrap it up with this, because as you see at this event that happened today, where Martin Hargreaves is at, the 6th annual Digital Transformation in BFSI Summit, and you see, plain as day, some of these key people, and I pointed out some of these key people, especially when it comes to Michael Drupstein, transformation lead, over at Gen AI and so on. But again, I want you guys to understand that all these people matter, and more in particular, they really, really, truly do, because when you get further down into it, what do you see on the bottom? Gold sponsor, Quant, the foundation of digital finance. Yeah, digital finance. That is absolutely incredible. And more in particular, it's understanding all of these key things, how it all comes together. And again, I'm so glad to share some of this, because sometimes, people just don't get it. They don't get it, and that's okay. But you want to know something? I think we are all starting to get it. And more importantly, it's understanding why it is a big deal moving forward. So with that said, that's going to wrap up today's QNT video. Simply do me a favor, if you stay the course to the end of the outline, and simply type this into the comments, and that is Martin, as in Martin Hargreaves, and I'll know that you listened to the entire outline. Really appreciate you guys listening to these outlines. As the saying goes, know what you have, know why you hold it. The research trumps FUD 110%. We will see you on the next one. If managing your crypto feels like solving a puzzle, it's time to switch to Decent Wallet. Say goodbye to complicated setups and hello to Decent Wallet, the hassle-free solution to your digital currency needs. With just a few taps, you can manage, track, and secure your crypto with unmatched ease. And here's the best part. Grab your Decent Wallet at a discounted price by using the referral link below. Don't miss out on making your crypto experience smoother and more secure.